Hey guys, welcome to day 4. This is Monday, March 23rd. Today's topic is electron configurations and sizes of ions. All right, first of all, we know that metals tend to lose electrons and they become positively charged ions or pussycats. Nonmetals tend to gain electrons and form negative ions. We call those anions. And remember, we always try to follow that octet rule, and that the number of electrons gained or lost is typically the number that will get an atom to a full outermost S&P sublevel. So 8 valence electrons being an octet. Obviously, the exception would be helium and elements in the first row of the table. So let's first of all just talk about a basic ionic bond. An element like calcium has 2 valence electrons. It's in group 2. And what calcium is going to do is calcium is going to lose those 2 electrons. And when it does, it now has a stable octet. Now, where are those electrons going to go? Most likely, they're going to go to an element like oxygen. So oxygen has 6 valence electrons, and if it gains those 2 electrons from the element calcium, this spot has been filled and this spot has been filled, and now oxygen has a stable octet. And when it gains 2 electrons, it will have a -2 charge. Now, when naming ions, metals keep their name, so we're just going to call it the calcium ion. And nonmetals, their ending changes to "ide." So oxygen will become the oxide ion, okay? So metals keep their names, nonmetals change to "ide." Now, if we want to write a formula, I think the simplest way to do that is through the crisscross method. I know you guys have been writing formulas. It's always good to review. So we crisscross and we get a Ca2O2. But remember, with ionic compounds, we always reduce it to its lowest whole number ratio, and we would call that its empirical formula. So the empirical formula, or the formula unit for the ionic compound calcium oxide, would be CaO. And remember, you always have to have a balance of charge. That's kind of the reason we crisscrossed in the first place. So this +2 charge is going to balance out this -2 charge, and we're going to have a neutral compound, calcium oxide. All right. When oxygen gains an electron, when oxygen gains 2 electrons, it's going to have a stable octet. And when calcium loses 2 electrons, it's going to lose those 4s electrons. And when it loses those electrons, now 3s and 3p become the outermost energy levels. So calcium loses 2 electrons to become like a noble gas, and oxygen gains 2 electrons to be like a noble gas. All right, let's do another one. Let's do aluminum oxide. So aluminum has 3 valence electrons. It's got 2 electrons in its outermost s, and it's got 1 electron in its outermost p. So what's going to happen is that aluminum is going to lose those 3 electrons, and we know that oxygen has 6 valence electrons, so it has room for 2 more right there. So now we have a ratio in which they are not going to combine in equal numbers. So easiest way to do this, I think, is the crisscross method. We take just the coefficient, or the superscript, the 3, and then we take the 2 from oxygen, and then we ask ourselves, can we reduce it? No, we can't. So the name of this compound would be aluminum oxide. I want you guys to realize that generally your transition metals are kind of exceptions to this octet rule. We've realized that the small number of elements underneath the stair table that are underneath the stair step considered to be metals also can kind of be exceptions. Oxidation states have been helpful in the past, so just realize tin. Tin could be a +2 or it could be a +4. Lead, also in the carbon group, could be a +2 or it could be a +4. Bismuth, I believe bismuth is down here next to lead, could be a +3, could be a +5. And thallium could be a +1, could be a +3. Just realize that transition metals and the metals underneath the stair step can have more than one charge, okay? All right, so what happens when atoms form ions? Well, metals tend to lose electrons. And when metals lose electrons, they're shedding their outermost layer. So if we have an element like calcium, its outermost shell probably has 4s2 electrons. Well, if calcium gives away these 2 electrons, now its outermost shell is energy level 3. So when a metal loses electrons, they're typically losing their outermost energy level and they become smaller. Now on the flip side, nonmetals typically gain electrons. And when nonmetals gain electrons, they tend to grow in size. So just remember, metals lose electrons, they shrink. Nonmetals gain electrons, they grow. And I've included this chart over here. All right, now on the left side, we see the metals. We see the ions in red, and we see the neutral elements in gray. And if you compare the radius of lithium, when lithium is an ion, it's going to have a radius of probably 90 picometers, but when lithium is neutral, it's going to have a radius of 134 picometers. So the red represents the ion and the gray represents the neutral. Now we come over here and we look at the nonmetals, like let's compare oxygen. If oxygen is neutral, it's going to be 73 picometers, but if oxygen gains 2 electrons from probably a metal, it's going to grow not quite double in size, but to 126 picometers. So nonmetals are actually going to grow when they gain electrons. Last thing today is this idea of isoelectric ions. Basically, elements that have the exact same electron configuration. So if we picked an element on the periodic table like neon, neon is atomic number 10. Now, fluorine can gain 1 electron to be like neon. Oxygen can gain 2 electrons to be like neon. And when they do, they still have the same number of protons as they did at the beginning, but now they have an electron configuration like neon. On the flip side, sodium could lose 1 electron, and when sodium loses 1, it becomes like neon. Or when magnesium loses 2, it becomes like neon. So all of these ions right here, oxygen, fluorine, sodium, and magnesium, when they gain or lose electrons, they become all just like neon. Okay. One thing you also need to consider is the size comparison. We already said that when nonmetals gain electrons, they're going to grow in size, and when metals lose electrons, they're going to shrink in size. So I have these all kind of laid out for you. Neon being the noble gas in the middle, oxygen and fluorine gaining electrons, so they're going to grow in size. Sodium and magnesium are losing electrons, they're going to shrink in size. So if you were to compare the sizes of these, oxygen would be the largest, magnesium would be the smallest, and neon would be nestled kind of right in the middle. So that's it for day number 4, guys. Remember, if you have any questions, you can leave a public comment on Google Classroom or email me directly. I miss you guys. I love you guys. I'll see you soon.